Hi students, good morning. Today we will study the conditions codes in the computer organization. Okay, computer architecture. Okay, now what is the necessity of the conditions codes? Okay, in the computer organization we have the processor. Processor will do the many operations. Okay, as arithmetic operations, logical operations, arithmetical operations like addition, subtraction like this, and also logical operations like and or like this. Okay, we'll do the some many operations. Okay, after doing the some operations on the bitwise we'll get the results. What type of result we are getting, we should have to know this one. Okay, based on that result we'll raise the result flags. Okay, so there are so many registers are there in the computer. Okay, like accumulator is also one of the built-in registers, and also instruction registers is there like this way. And also we have the processor registers like the okay B, C like this, and D like this. Okay, and also program counter is also one type of register, but not the, it will not only store the address of that one. But here the after the performing the some operations, the only the thing is the result is to be stored where in the arithmetic logical unit in the accumulator itself. What are the result we are getting? That result, what type of result we are getting? Okay, we will be deciding. Okay, that is to be done. The based on that result only we will raise the some flags. Flags means for some bitwise bit operations. This type of result I am getting. Okay, let me see how the conditions codes. Conditions codes. Okay, the processor keeps on track on the information on the results of various operations for use of subsequent condition branch instructions. Okay, after performing the some operations our processor will keep track on the result, what type of result getting for the furthermore operations, for furthermore execution of the instruction. This is done by the recording of what recording of the required information in the individual bits called as the conditions code. This will be done. Okay, what type of result we are getting? This is recording means what we are analyzing the result. Okay, the processor will analyze the result here. What type of result you are getting, that is to be given. Okay, to user to tell. This is called as the with raising the some flags means what, some conditions flags. Like if you are getting the result as the some zero result, complete whatever the operation we are performing, after the performing we will get the result. What type of result? Completely result 2 minus 2 is what, 0 only. That's the result is what type of result, 0. That type of results to be displayed. Okay, tell to processor that's to be raising what the condition flag, that 0 flag is will be raised. This is the, these flags are grouped in together in a special registers. Okay, in the special registers, what type, this is register we call this what the, what is that, condition code registers or flag registers, or else we can also say as the status registers. The registers, okay, the whatever the result we are getting, that is to be bit by we will be storing that one. Or this complete these flags. Okay, around 6 flags we are getting: zero flag, negative flag, sign flag, and also auxiliary carry flag, and also parity flag. Like this will, these are flags whatever getting the result. Okay, after doing the operation we'll get the one flag, after doing the some result we'll get the zero flag. What are the results? These 6 flags, these 6 flags are stored where in the one register, that we call as what, the status register or flag registers or condition code registers. Okay, got it? Condition code registers, these are the flags. Okay, grouped in together in a special registers called as the status register or condition code registers, or else flag registers. Got it? Okay, is it clear for you? Understood now? Okay, next term. The individual code flags are set to what, the 1. If it is a 0 result we are getting, then the 0 flag will be set to what, the z equals to what, the 1. If it is a 0 flag is not result is not the 0. Okay, if it's something else, then the this flag is set to what, the 0. What it means, what if the flag is 0 flag is raising means what, the complete result should be what, the 0 bit, then only z equals to becomes what, the 1, then the z flag is raised, what we call the z flag is raised. Otherwise result is not a 0, then z equals to what, the 0, then the z flag is not raised, z flag is not raised. Okay, like this we'll have the around 6 flags are there. Okay, around 6 flags are, we'll study one by one. Okay, around the in the microprocessor, the processor itself we have the 6 flags are there. One is what, first one is called as the negative flag or sign flag, another one is called the zero flag, another one is called the carry flag or borrow flag, another one is the overflow flag, another one is what the fifth one is what they call the auxiliary carry flag, fifth the sixth one is called the parity flag. We'll study the one by one. Now copy this one, completely copy this one. Okay, copy thing. I hope you are, is it clear for you? It is clear now? Okay, just to copy the things whatever I written on the board. Okay, once again I will be explaining this one only. Conditions codes are the processor keeps track on the information what the operation is doing, what type of result you are getting for the various operations for use of subsequent condition branch instruction. This is done by what the recording of the required information in the individual bits called as the condition flags, condition code flags. Okay, these flags are grouped into in a special registers called as the status registers or flag registers or condition code registers. Okay, is it clear for you? If the particular flag is raising, if the particular result is 0, whatever that, if the particular flag is raised, then that flag is set to what the 1 means what the that is that particular flag equals to 1, otherwise it is a 0. It means what the particular flag is raising means particular result what we are getting, it is clearly telling that that type of result we are getting here after the performing the operations. Okay, just copy the things whatever are written on the board. Okay, I'll clear the things whatever the one by one. Okay, around the 6 flags are there. Okay, one is called that one we will clear. Okay, we'll study one by one just to copy the things whatever are written on the board. Okay, as I already told you that there are 6 conditions codes or 6 condition flags are there. How many? 6 condition flags are there in the computer organization. Which are those? N is what the negative or sign flag, Z is what the zero flag, another carry flag, carrier borrow flag, or overflow flag, auxiliary carry flag, parity flag. Okay, as I already told you, this is the status registers or flag registers or condition code registers. Which is having the what the size 8 bits in size. Okay, remaining 2 are called the which is not used. Okay, which these 2 bits are not used, but these 6 bits are used for the raising of that. Okay, if the n is equals to 1, then the result is what the negative flag. When z is equals to 1, then the result is what the 0 flag. If the carry flag is raising, then this particular bit is raised to is equal to what the 1. Otherwise, it's 0. Like this, force flag is set to what 1. Otherwise, it's 0. Auxiliary carry flag is set to 1. Otherwise, it is 0. P is equals to 1. Otherwise, it is a 0. Okay, parity flag. We will study one by one. Okay, this one is called as what the status register. Status registers are flag registers or conditions code flag registers. Okay, next we'll be studying the one by one. First one is called the negative or sign flag. What is the negative or sign flag? If you are the result, whatever result we are doing the performing the some arithmetic operation, the operation we are after the result of the operation, if the result is what the negative, then the particular flag is will be set to what the n equals to 1, n equals to 1. Otherwise, it's 0. If the number is the positive number, if the number is positive number, positive result, then the n equals to what the 0, n equals to 0. Okay, n equals to 0. We will be studying the one by one. If it's a we will consider the flag will be raised. Okay, for example, addition of the two 4-bit numbers. Let me see it. -4 is to be considered. Another one is the +6 is there. Okay, if you are doing the addition between these two operations, if the result is what the negative number, then the how to see it. Okay, for this 4 can be expressed as the in the binary form 0 1 0 0. This is what the real binary number of the 4. Okay, I have to express this negative number. Okay, how to make it? So I have to get the 2's complement of this number. How to make it? Okay, change the 1s to 0, 0s to 1, 1 0 1 1. Okay, I have to make it so this is what the 1's complement. I have to get the 2's complement form. No, then I have to add the 1 to this one to the 1's complement number. Okay, 0. This is what the 0. This is what the 1 1. Okay, I got the this is what the 2's complement of the 4 number. Okay, just I am writing the 2's complement form. This one 1 1 0 0. Then the 6 is the positive number. I have to make it so that as it is. Okay, 1 1 0. Then the addition between these two numbers is let me have it. Okay, 0 0 is 0, 1 0 1 1 1 is what the 0 1 is the, okay, 1 1 is what the 1 0. This is what the, this is what the, this is what the, we are getting what the answer here, the, but this is what the overflow is getting. And also we are get this, we can say it's what the, we are getting what the positive number. This is what the positive plus 2. This is what the, we have to neglect this number. Okay, more than the 4 bits, we have to neglect this one. We can say it's the overflow is happening, but the, we are the, whatever the result we are getting, this is the sign. Okay, dot sign type of sign, this is the positive number, not a negative number. This is the plus 2. Like this we'll have the, if it, then the negative flag n equals to what the 0. If it is a negative, if it is a result is what the fourth bit of the, this one is what the negative, means what the 1, definitely the n will becomes what the 1, then the n flag will be raised. Similarly we can get it. Okay, you can, and also if the 0 flag, next is what the 0 flag. 0 flag is, is nothing but if the result is analyzing. Okay, if you are doing the operations on the, between the binary operations, like operations between the binary operations between the two numbers, then the result is what the 0, definitely the 0 flag should be raised. 0 flag should be raised. Carry or borrow flag, carry or borrow flag. Carry or borrow flag means what the, if any carry is happening between the two numbers, 2 bits, then the, we can say it's what you can say it's what the, is set the carry or borrow, carry flag or borrow flag is set. Overflow means what the, if the any number is, if flag is raised, okay, is set to what the overflow flag is set to 1 1 1, we can say it's what the, if the more than the fourth bit, okay, more than the fourth bit we are getting the any numbers, then we can say it's what the overflow flag. Okay, auxiliary carry flag, if any carry between the two numbers, between the two numbers, two 8-bit numbers, if the carry between the, from the fourth bit to 0 0 0, this is what the 0, then from the fourth bit to fifth bit is carry is happening, then we can say it's what the auxiliary carry flag is set to 1. Auxiliary flag carry flag is set to 1. Parity flag, if the result is after getting the result, okay, whatever the result we are getting 1, this is 1, okay, then we can say it's for the, here the 1 1 is what the 1 0, yes na, we are getting 1 1, okay, this is what the 0 1, this is the overflow, this one gets what the overflow is happening between. And also parity flag is our number of ones in the result. If the number of ones is even number, then the even parity flag is set to what the, is set to 1. If it's a number of ones are not equal to 1, okay, number of equal not equal to even numbers, then the parity flag is set to what the, not to set to 0. Okay, then the parity flag is here the 1, number of ones are in how many, 1. This is what is the odd parity flag, means what the parity flag is set to 0, means what the even, not a even numbers are say here. Okay, parity flag is because of the number of ones in this result is what the only one. Like this we have the, how many flags are there, negative or sign flag, 0 flag, carry flag, overflow flag, auxiliary carry flag, and also parity flag. Okay, remaining 2 are not considered in this bit. Okay, like this. I hope is it clear for you. Okay, I hope it is clear for you. Okay, next we will move to the another concept. Okay, before going to the another concept, let me revise once again. Okay, there are 6 conditional flags in the computer organization in the in a processor. How many are there? Negative or sign flag, 0 flag, carry flag, overflow flag, auxiliary carry flag, parity flag. Okay, like this. Our means what the 8 bits are the flag registers, but the only 6 bits are used. Okay, remaining 2 are not used. Okay, now which are those? Negative or sign flag, 0 flag, carry flag, overflow flag, auxiliary carry flag, parity flag. Okay, you have to explain this like this. Okay, I hope it is clear for you.